So this is a Bohr model of the atom, and we have some positive charge in the center here, and these are neutral, and these are negatively charged. These electrons buzzing around the outside. Electron mass. I might write the masses here. Mass of a neutron, m sub n. Does anybody know the number? Does anybody know the order? Minus 27 kilograms, yep. Mass of a proton, 1.673. 10 to the minus 27 kilograms. And mass of an electron. Yes. 9.11 by 10 to the minus 31 kilograms. Considerably less massive than both protons and the neutrons. The protons and the neutrons together, protons and neutrons are collectively called nucleons, part of the nucleus, particles that make up the nucleus. Charge, what about the charge of the electrons? Charge 1.6, you know this number, by 10 to the minus 19 coulombs. Charge of the proton. Tablet stopped working, hang on. Go a bit slow for it. Charge, proton, also 1.6 by 10 to the minus 19 coulombs. Now, except this is kind of positive and this is kind of negative, okay? We say they're opposites, but they're equal in magnitude. And so what that means is that this is an electrically neutral atom, as long as it's got those two electrons buzzing around the outside. Okay. Why doesn't the nucleus fly apart? Nuclear force, yes. Yeah, so the nuclear force. Another name for it? Yeah. Strong force. Or strong force. Why the strong force? Stronger than the weak force, that's true. Relative. Strongest known force that we know. Okay, so strong force. What we know of the strong force, it's the strongest known force. Very short ranged. It acts only over a nucleon, couple of nucleon diameters. It says here in the text a few, so works over only a few nucleon diameters. At short distances, at very short distances, nucleons are attracted to each other. At extremely short distances, so more than very, at extremely short distances, nucleons repel each other. Lucky for us, they do, because otherwise there'd just be a mess in the center there. That strong force would cause them all to become kind of one thing. The question why, I don't know why. Not sure that anybody knows why. We can only describe the rules. We can't say why in physics often. I know it's disappointing. The force is independent of the type of nucleon. So it doesn't matter if it's a proton or a proton or a proton or a neutron or a neutron or a neutron or a neutron or a proton. They all act the same with regard to this strong force. Okay. It's lucky for us that this is true. Somebody asked in the other class, how do we know all of this? How do we know the mass of protons? We put them on scales? Are we? Yeah, okay, right. Well, the scales have to be made of something. Okay, so now what about if you look at, if I were to take a radioactive substance that emits alpha particles, say, alpha particles are just helium nuclei. Okay, we'll talk about this in radioactivity a little bit more, but there's an alpha particle, and then I find a big nucleus, or maybe more specifically, gold nucleus. There's a good one here. Here's our gold nucleus, and they're actually probably, that's a little bit big. Make it a bit smaller. I don't know whether that's the scale of the two. That's a roundabout. And I fire. How do I get a gold nucleus? Well, I get some gold sheet that's very thin. Gold's very malleable, can be beaten into very, very thin sheets of only a few atoms thick. If I fire these alpha particles at that gold nucleus, what happens? Well, they get close to it, but they never actually touch it. Yeah, it's the electrostatic force. When they get very close, they can turn around and come back. That's unusual. They can go off in different directions. They can actually, at certain distances, they can really turn. Okay. Now, if we map this, and a guy called Rutherford mapped this, in the early 1900s, 1925 maybe. If we can map this, we can see, and because of the way these things interact with each other, we can kind of see their momentum. If we know how fast they're going, and we know at what angle they deflect at, we can kind of know their mass. There's some calculations that can be made. Thank you. See you tomorrow.